Okay, so now for something that's not at all technical, some of which we had this morning. So I'm going to be talking about the U.S. Bureau of Reclamation's Project Skywater, which was a weather control project from the 1960s. The idea being that if you didn't have water where you wanted it, you could get the precipitation to fall where you wanted, when you wanted, and just exactly how much you wanted. And it was just going to save huge amounts of money for the U.S. government at a cost of tens of millions of dollars a year. So let's take a look at, okay, how did we skip one of these? Okay, so I'm going to go back and explain exactly what weather control is and how we got to the point where they thought that they could do this. And so the idea of weather control is really quite old, as you can see from this BC cartoon, where you can get a giraffe that slobbers if you have a couple of clams. And it's a little bit advanced beyond that at this point, but not necessarily a whole heck of a lot as time went on. So for people who work in environmental history, which I kind of straddle between environmental history and history of science, so in environmental history, we talk a lot about how we control nature. And most times when we're talking about controlling nature, it's really local. I mean, even if it's a big project, it's basically local. So if you're doing levees, or if you're putting up dams, or if you're draining swamps, or if you're tunneling through mountains, that's control, but it's really pretty local. But when you're talking about controlling the weather, you can't just do that one place and not have it affect every place else. And so weather control becomes a global control, which makes it fundamentally different than other kinds. And essentially, weather control is about water, okay? So it's about water that's coming from the sky. It's about fog that you either want to create or get rid of, depending on what your purpose is. It's about snowpack in the mountains that's then going to run off in the summertime and provide water that's going to fill up your irrigation canals or fill up your reservoirs. If you're using it in a from a military standpoint, then what you're saying is, oh, I can make my weather favorable for my forces and I can make it unfavorable for the other forces. So all different kinds of ways that you can look at it. But essentially, it's about water. And when you're talking about water, as some of our speakers this morning had noted, yes, you need air, but you also need water, right? And you need clean water. And in the United States, people looked upon having a lot of clean water, in other words, enough clean water to waste, as being a sign of an advanced civilization. And in fact, the more water you could waste, the richer you were, right? If you weren't a rich nation, then you had to kind of reserve your water back and make sure that you had enough to get for everybody to get around. But if you were very wealthy, then you had water to waste. And so what the United States really wanted was water to waste. And so that's what they were looking at doing. So how did they come up with this, and what were they thinking at the time? Well, in the 19th century, way before we had weather control, we had rainmaking. And the person who was a main push behind rainmaking at the governmental level was James Pollard SB, who was a meteorologist, as much as anybody was a meteorologist in the 19th century, because meteorologists didn't really exist in the 19th century. But he described himself as the meteorological advisor to Congress. Congress didn't label him that, okay? He was self-proclaimed as the meteorological advisor to Congress. And he was an early proponent of rainmaking. And so he came up with this plan. And so think about where the Rocky Mountains are and how the mountains extend basically from the border with Mexico all the way to Canada. All right, so it's not the Rockies the whole way, but you know the drill. Okay, so we've got all these mountains here that you have to get past. And he said, just think about this. He said, what if you took 40-acre tracts of timber and slash and scrub and all the stuff that all you farmers want to get rid of anyway, and we put it in 40-acre tracts, and we had those 20 miles apart, starting at the Mexico border and going all the way to Canada on the east side of the Rocky Mountains. And then we torched off each one of those piles of brush. Got this? Okay. We're going to torch off each of these piles of brush, and then the smoke is going to rise up, and then the westerly winds are going to carry that smoke towards the east coast, and as it goes along, it's going to be grabbing water particles, and then it's going to rain gently when it gets to the west coast. I mean, what kind of a plan is that, right? And so he goes and he makes this pitch to Congress. He said, really, we need to do this. And cooler heads prevailed. The guy who was the head of the Smithsonian said, okay, no, we're not going to do that. No, we're not going to do that. Okay, we're going to think about something else. However, that did not mean that we didn't do it. And so come along about 1890, there is a plan hatched that would give $2,000, which was a lot of money in 1890, to the Department of Education, Department of Agriculture, to have them do what I call shock and awe rainmaking. And so what were they supposed to do? Well, they were supposed to go out and set off a whole bunch of ordnance when it was cloudy, and that was going to make it rain. And why did they think it was going to work? I mean, you know, like you have to have a reason. And the reason was that if you looked at battles, at the end of the battle, it always rained. So what could possibly have done that? All right, well, so since this had been talked about since the time of Plutarch, before they had artillery and they were just kind of stabbing people to death, at that point the idea was it was at the end of the battle because people had bled all over the place and sweated, and then you had all the stuff evaporating, and that's what made the clouds. But by the 19th century, the idea was it was the smoke from the artillery that was going to mix with the clouds, and that was going to make the rain, and that's why it rained. The fact that these wars were taking place in the mid-latitudes, where during the season where you've got frontal passage coming through, a new front comes through every day, and it rains no matter whether you're firing off cannons or not, made absolutely no impact at all. And so there was a guy who'd done a book called War in the Weather, and he documented all of these battles that had rain at the end. Of course, there were lots of battles that had no rain in the end. He left those out. And he just left in the ones that proved his point. And then there were people who really thought that this was a good idea. Okay? And so here we are. So 1890, and so the guy, do we have a pointer? Someplace? No, I guess not. All right. So the guy on the left there, his name was Dyrenforth, okay? Otherwise known as Dry Henceforth to most people. And he referred to himself as being a general, and he wasn't a general any more than James Pollard Espy was the meteorological advisor to Congress. But he worked for the U.S. Patent Office. And what had happened is that a member of Congress, actually a senator from Illinois, was part owner of a 3 million acre ranch in Texas, in the Texas Panhandle. And he said to himself, you know, our land would be worth a whole lot more money if we had water on it. And it's going to be too expensive to do irrigation. So he was the one that cooked up this plan for the $2,000 appropriation for literally making rain. And when the House got it, they said, no, you know, like you can't make rain. And they took out the appropriation. When it came back to the Senate for reconciliation, they put it back in, but they just put a number on it and didn't explain what it was. So it sailed right through. So now they've got this $2,000. They give it to the Department of Agriculture, specifically to the Forestry Division, because that was considered the science unit at the time in the U.S. government. And they said, okay, here you go make it rain with artillery. And they said, no, we are not going to do this. Is ridiculous. It's not going to work. And so that's when they went to the patent office, and that's where Dyrenforth worked. Okay, he worked at the patent office, and he said, I can do it. And so they took all of this explosives down to Midland, Texas. So this is a drawing from the time. And what they did was they filled that balloon that you see there with a combination of oxygen and hydrogen gas, which is suitably explosive. And then they had cases of dynamite that they put in boxes that were lifted up by the balloon. And they connected the whole thing to a battery. And the line went up, and they floated the balloon up, and when it got to cloud level, then they'd touch off the whole thing and it would explode. Okay? That's the idea. Well, and it did. That's what they did. Scared all the cattle, right? The longhorns are all running around all over the place. And it rains. But guess what? It was going to rain anyway, which is exactly why it worked, which was the whole problem with this. And that's the joke here, because that guy with the telegram there, he's coming with a thing that says it's going to rain. That's the forecast. And so now they're going to torch it off. So they went ahead, and they did. And the news reports were fabulously positive. They made rain in Midland, Texas. I mean, you know, it was like, I called it the tweets of the 1890s, right? You know, Dateline, Midland, Texas, rain falls, you know, cows cows running crazily through the grasslands. So they came back and they asked for more money. Of course, I mean, that's what you do, right? So they asked for more money and they made another trip. They went down to San Antonio, and it didn't work real well in San Antonio. And in the meantime, a new Secretary of Agriculture had come in, and I don't have documentation to prove this, but I can tell you that he took his unspent funds and he gave it back to Congress, and I can't think of any other organization that's ever given back appropriated money, ever. So even though it was discredited in the scientific community, the public was really agog over this idea that you could make rain on demand. And here is Farwell. Okay, he's the guy who was doing it, and you can see that's where his ranch was. Big flop, it pretty much dies after that. Okay, so then what do we have happen? And actually somehow, okay, I'm going to go to this slide. Somehow the slides, I had a PowerPoint disaster this morning. All right, let's just put it that way. So this is Charles Hatfield, and Charles Hatfield was known as the Rainmaker in California. There was actually a movie that was done about him. It starred Burt Lancaster many years ago when Burt Lancaster was a young guy. That was a long time ago. And here he is with his secret chemicals. No, that is not bootleg gin, even though it looks like it. And what he would do is he would build towers, and he would put a tray on the tower, and he would put his chemicals in there. And then supposedly the chemicals were what was going to induce the rain. And his deal was with supporters is if it didn't rain, that they didn't have to pay him. But of course, he never put the chemicals up there until he contacted the Weather Bureau to find out when the next front was coming in. So he already knew that it was going to rain before he put the stuff up there. And then he would get paid, and then he would get yet another customer and another customer. Well, at one point, the city of San Diego hired him to make rain for them. And they really hit the jackpot. They had so much rain that it actually blew out one of their dams and caused a considerable amount of damage, whereupon they sued him for creating too much rain, whereupon the judge in the case said, you can't do this. Nobody can make it rain. I don't care whether it did in your dam or not, right? And so Hatfield very brightly got out of town at that point and went off to other places. So we don't see a whole lot more of this being done, some mostly out in the U.S. West and in Western Canada, but the U.S. government gets involved again in the 1920s with this plan for using electrified sand. So the deal here is that you grind up sand to be the appropriate size, and then you give it a charge, either a positive charge or a negative charge, depending on what you think the charge of the water droplets in the clouds are. So the idea was if the drops were negatively charged, then you would positively charge this sand, and then you would go up in an airplane, you'd charge it, and you'd spit it out the airplane, and then it would glom on to the water particles, and it would become heavy enough. Okay, it's a little, thank you. Okay, and it had to become heavy enough to fall out. That was the deal. So the U.S. Army was really jazzed up about this because the planes that they were flying at the time, if you've seen planes from the 1920s, weren't all that sturdy, and of course there weren't any instruments. There was no instrument flying. So the idea was you didn't want icing either. So the idea was you would have this thing in the back of your plane. You would fly up. You would fly underneath the cloud deck. You would spew this stuff out. It would make a hole in the cloud. You'd fly your plane up. You'd go wherever you were going to go. When you came back, you'd do the same thing, only on top it would make a hole, and you'd dive back down and you'd find your field. That was the idea. The brains behind this was a guy who claimed he was a physicist at Cornell, but really wasn't a physicist, nor was he at Cornell. And he enticed a chemistry professor from Harvard to do much of the work for nothing. I mean, Harvard, I don't think, ever got reimbursed. I was in the Harvard archives, and I could never find a place where they were reimbursed. The Army was supposed to be providing funds. The chemist ends up having a nervous breakdown. And the Army ultimately gives up on this project. But you can see here the cute little cartoon for how you could make your own rain, you know, with electrified sand coming out. So they had these generators. The whole thing was just really wild. Okay, so that's where we are until we get to the modern stage. People would have liked to have done weather modification during the Dust Bowl, but you have to have clouds first. and there weren't any clouds during the Dust Bowl period, and so the whole thing really kind of dies away until the war comes. And more specifically, after the war comes is when we really see this take off. But during the war, we have this guy, Irving Langmuir, who was a Nobel Prize winner, worked for General Electric, and he had lots of government contracts for the US military, and he was working on cloaking smokes. That's what you see here, the cloaking smokes. And he was also working on aircraft icing. So you all know, because if you've flown any place in the wintertime, outside of Tallahassee, which doesn't have a big icing problem. But even if you've been in Atlanta, you've probably been delayed because your plane had to be de-iced, right? And had to have de-icer on it before you took off. During the war, they weren't really good at de-icing yet. And a helicopter with ice on its rotors is really not a place that you want to be unless you want to just do one trip in that helicopter, right? As it slices down through where you are. So he was working on this, and what he noticed was that not all clouds precipitated. And so he wondered, why is it that some clouds precipitate and some clouds don't? Realizing at the time that meteorologists didn't know why some clouds precipitated and some didn't. I mean, nobody knew. And he surmised that the clouds that precipitated had what he called ice nuclei in them, and that those ice nuclei would preferentially grab on to the water particles, and it takes 1 million cloud droplets to make a drop that's heavy enough to fall out. All right, so that's what they're looking at. They're looking for these little pieces that are going to grab onto these 1 million little droplets, which will then be heavy enough to fall out of the cloud. So that's what he's looking for. All right. So what did they do? They're trying to figure out what they can substitute for these little ice particles. And so here we are at General Electric. This is Irving Langmuir. This is Bernard Vonnegut, who was Kurt Vonnegut's brother, and Vincent Schaefer, who had dropped out of high school when he was a sophomore so that he could help support his family, was just a completely brilliant guy, and with no formal education at all, becomes one of the foremost researchers in this field within a few years. And so here they are with, and I'm at pains to tell you that is a General Electric freezer. Okay, General Electric is very firm about that. Okay, that this is GE freezer. And so they put this GE freezer in, and they lined it with black velvet so they could see what was going on inside of it. And what Schaefer would do, since he was doing the experiments, is that he would make a cloud in the freezer by blowing into it, just like we do on the occasional cold day we have here in Tallahassee. Okay, you blow into the freezer, you make a cloud in the freezer, and then he would dump in every little bit of chemicals that they had there, and so he'd blow in, he'd make a cloud, he'd dump them in, he'd blow nothing. Okay, on to the next one, right? He went through everything in their lab. Nothing was working. And in the summer of 1946, he said, I just don't think this freezer is cold enough. So he goes and he gets a hunk of dry ice and he pitches it into the freezer, and he's greeted by a snowstorm. And he said, whoa, look at that. It's a snowstorm. So he shaved off just a little bit of dry ice and he pitched that in there, and he got another snowstorm. And so he did it smaller and smaller and smaller, and each time he got a snowstorm. At one point, he chilled a needle, a sewing needle that he had on a thread, down to minus 40 degrees, which at Celsius and Fahrenheit is the same temperature. Another little cool fact. And when he swung it through, he'd blow into it. When he swung it through, it would basically make a blue track that went through as everything cleared onto it, right? And so then you'd have these little crystals that followed in the wake of the needle. So he let Langmuir know, and Langmuir said, okay, I'll do the math, right? So Langmuir figures out what the theoretical part is, and Schaefer takes 2.5 kilos of crunched up dry ice, a Fairchild aircraft that's like a Cessna, goes up with a pilot out of the Schenectady airport, which is where GE was, flies out, and they start looking for some unsuspecting little cloud that's minding its own business. And so they found one. They found this little stratus cloud that was just sitting there minding its own business, and they pitched the stuff out the front window or the side window of the cockpit. I mean, literally, out the window it goes. And Langmuir was at the landing strip, and he's watching with field glasses, and he watches the entire cloud burble up like a big cauliflower, start snowing, and then the whole thing collapsing on itself. He says, whoa, way cool. I can get money for this, right? That's what he was thinking. I can get money for this. And he does. It's called Project Cirrus. And so they got this old B-17 bomber left over from World War II, and a nice big wad of money from the Defense Department. And they said, go for it. And so now we're back out to putting holes in clouds. And so here we go. There we go. We've got our hole in our cloud. And this is the same thing as with the sand. We're going to fly in. We're going to make sure that we can clear out a hole. We're going to come up. And then when we come back, we're going to do the exact same thing. Well, people were really interested in this. I mean, particularly the military people. But then commercial people got interested too. And the person who got interested was this guy, Irving Crick. Okay? Irving Crick was at Caltech in the meteorology department. He is most famous for being the self-proclaimed forecaster for the D-Day invasion. His forecast was not accepted. It would have been a disaster if it had been. But that's, you know what? I'm getting a note saying that this is going to power off. Is it not connected to power? There we go. Okay. All right. Okay. Now I feel better. Thank you. All right. So Crick worked for Caltech, and his big claim to fame at Caltech was that he did the forecast for the scene where the big mansion burns at the end of Gone with the Wind, right? So he was doing all these forecasts for the Hollywood people, and he was doing forecasts for the airport, and he had a tremendous business that was being built up, and he actually became quite an embarrassment to Caltech, to the point where Caltech closed their meteorology department down so that they could fire all these tenured professors that worked there. And so Crick and all of the people who worked for him all left, and they formed a private outfit to control the weather and to make long-range forecasts. So it's a little sidelight here, okay, not related to the weather control part. So he would tell people that he could make a forecast for them a year in advance for what would happen on a specific day. And that he was so confident that he would be right that he would put the forecast into a safe deposit box. And at the end of the year, they could come back and they would see that it was the right thing. What he didn't say was he had safe deposit boxes all over town, each with a different forecast in them. And then he would pick the one that matched what happened during that day. And then they said, you know, by golly, you're right. You know, like, we'll use your long-term forecasting project. He was later kicked out of the American Meteorological Society. I just want you to know that this is who we're dealing with here. And so he had a weather control business, and he used these ground generators. Okay, so Bernard Vonnegut, realizing that the whole dry ice thing was going to be very difficult to use long term, said we need to find another chemical that'll work. And the magic chemical was silver iodide. Fortunately, not lead iodide. That would have been more of a problem. That goes back to the Flint water thing. Okay, but what they did was they took charcoal briquettes and they soaked them in silver iodide that was dissolved in acetone. And they'd let them soak there for a while. And then they took them all out and they dried them off. Then they put them in the bottom of one of these things here, and then they torched them off. So this is actually connected to a butane tank over here. And then they burned it, and the smoke comes up, and it sends the silver iodide seeds up, and those silver iodide seeds do the same thing as the dried ice. They glom onto the little cloud particles, and that makes it rain. Okay, so he is selling his product all over the U.S. And so here we have, this gives you an indication by the late 1950s, all the gradient areas where weather control is underway, where this cloud seeding is. And I was really kind of surprised by all of this, but that was because we had drought conditions on the East Coast during those years. At one point, all of New Mexico was being seeded. The state of Washington was being seeded here. And they had all kinds of weather wars going on here because the wheat farmers needed more rain. The cherry farmers wanted to make sure it did not rain when they had cherry blossom times or when the cherries were ripe. And so the wheat people would seed for rain and the cherry people would seed for no rain at the same time. And you can do that by putting so many seeds up that it dries up the clouds. And so they were filing suit against each other, and then they both quit seeding, and then there was a huge storm, and it wiped out the wheat crop, and it wiped out the cherry crop at the same time. All right, so what happens as a result? Why did that go away? Oh, it's okay. All right. So the Congress people,
No, you're fine. fine. The screen's not fine.
Oh, the screen's not fine. Okay, that's why. There. No?
Yeah.
Yep, there we go. All right. So because places like Washington State were having a problem with suits and countersuits, they started appealing to their Congress people to do something about it. So 3 bills were introduced. Actually, over time, lots more than 3 bills were introduced, but these were introduced in 1951. So we have Senate Bill 222, which would have licensed weather modifiers and placed them under a weather control commission that was modeled on the Atomic Energy Commission, which is fascinating since we couldn't control the weather to begin with. Okay, we could split the atom, okay, but we couldn't control the weather. Then there was another Senate bill that was about conducting research into the control and production of moisture in arid areas, and Senate Bill 5, which also had to do with desalination in addition to weather control. And the person behind these was Senator Clinton T Anderson of New Mexico, who had previously been the Department of Agriculture Secretary. So he really wants to bring water back to the state of New Mexico. And the co-sponsors are almost all from the West, and they want water in their states as well. They want nice, gently falling water, and all weather modified rain is gently falling. Okay, there are no heavy rainstorms that come. I'm just telling you this, okay? According to the people who did this, there was only gentle rain. And so they wanted gentle rain, they wanted where it was, and he was going to provide it. The big deal was, why do this? Well, because it was going to be cheaper than irrigating and putting in more dams and putting in more reservoirs and putting in more irrigation canals. If you could just get the clouds to come in and rain where you wanted it for the right amount of time, it was going to be cheap, okay? A lot cheaper than doing it any other way. So he makes this pitch and introduces these bills. And the head of the Weather Bureau, Francis Weicheldorfer, seen here, who always looked that way, near as I can tell, was in Paris for a conference. And he just wrote back and he said, this is just not going to work. We don't know anything about cloud physics. We're still trying to figure it out. We can barely get a forecast out for the next day. And now you're telling people that we can control it? This is not going to work. So like, no. You know, like we need to not have another plan. Anderson looked at him and said, you're just being negative. We do not give money to people who are negative. We do not give people money who are going to prove that something can't be done. We're going to give money to people who can prove that it can be done. We're going to give it to people like this guy from GE, okay? This was C. Guy Suits, and he was Langmuir's boss. And so when he was giving his testimony, he says, you know, weather control is just like atomic energy. It's essential for national defense, and it's essential for economic health. And we know how to do it. And because we're such good people at GE, we're going to give you every piece of information we have about doing this. We're not going to patent it. It's all free to the government because we're just really good guys. All right, you know, like what do you do with that? Okay, well, you decide that you're spend some money on it. And so another couple of senators who were involved were Francis Case from South Dakota and Lester Hunt from Wyoming. And here's where you find out just exactly what these guys knew and didn't know. And so in the middle of the hearing, Lester Hunt, who's seen there on the right, starts yelling at Francis Case on the left that South Dakota is stealing Wyoming's water. Now, the fact that the air goes from west to east and Wyoming is west of South Dakota had no effect on this argument, right? As Case is trying to say, but we can't steal your water. It's already gone past you before it gets to us. And Hunt says, I'm telling you, I know that you're stealing my water, and I don't want you stealing my water anymore. And Anderson's saying, could we get back to the testimony, please? We really want to hear from Interior, okay? So the people at Interior were big weather control supporters. And they are thinking about ways so that they don't have to be pumping groundwater and they don't have to be building any more dams. Chapman's assistant gets up there and he's saying, my goodness, he said, we can not only have it rain wherever we want it to rain, we can snuff out tornadoes. And then we won't have any tornado damage either. My goodness. Okay, we got all kinds of, you know, the feds needed to be in control. absolutely need to be in control. Florida gets into it. Here we have gorgeous George Smathers. And he's saying, I don't understand what the problem is. He said, we don't necessarily need all the water to land on the windward side of mountains. We need it on the other side too. So we need to put a rudder on those clouds and steer them around so that it rains on the other side of the mountain. Now, there are meteorologists that are testifying there. They are pulling their hair out, okay? They cannot get across to people that this is not going to work. And every time they mention it, they are told they are being negative and reactionary, and they're not looking forward to the future, which is when all of this water is going to come out of the sky. So bill after bill, year after year, nothing really gets accomplished. And so finally, the Senate decides to put together what was known as the Advisory Council on Weather Control. And that group of people got together and examined everything that had been done so far. And they recommended that the money be turned over to the National Science Foundation and for them to run the studies. Good idea. So Senate Bill 86 did that. Gave National Science Foundation $5 million over 5 years in 1957, which was really quite a bit of money in 1957, $1 million a year. And that brings us to what happened next, okay? What happens domestically? There's things that happen militarily. That's another talk. So the Weather Control Commission dies on the vine. It never even gets started. But that doesn't mean that there aren't people in Washington who want to see this happen. And the people who want to see it happen are at the Bureau of Reclamation because they already have all of these dams and reservoirs. So wouldn't it be ideal if they could get it to rain in the watersheds that fed these dams and reservoirs? Then they wouldn't have to worry about things anymore. And the person behind this was Floyd Dominy, who was the Bureau of Reclamation commissioner. If you've ever read the book Cadillac Desert, you know all about Floyd Dominy. He never met a stream that couldn't be dammed in more ways than one. And so his opening gambit was that too much of weather control had been theological. That is, people prayed for rain. And he said, we've got to get away from that and we've got to go with the engineering concepts here, okay? And away from this faith-based weather control. So he's looking at, and he argued, he said, look, we've already got dams like the Glen Canyon that's coming online, and it's going to have Lake Powell behind it, but this is an arid area, and so we need more water that's coming in here. And we have to consider what's going on in the country. So he noted that the darker areas there are where they anticipated that there would be a greater change in population from 1950 to 1960. This doesn't really change much in the 60s, so I'm showing this. So this is the situation, and you can see that we've got all this growth in the West. Well, Bureau of Reclamation was restricted by law to the 17 westernmost states, and Dominy really wanted to be able to control the 50 westernmost states, right? Well, or 48 at the time. Well, 50 by the time Alaska and Hawaii come in. And so he really wants this to happen, and so he needs a way to argue that this is important for him to take over. So they produce a number of reports, and notice here, this one is about water deficiency. So the crosshatch area here, this crosshatch area here, is where they are looking for water supply to be deficient by 1980. Here in California and a couple other places, they're looking for water deficiency by 2000, and then the really wide water and approaching water deficiency by 2000. Interestingly enough, look at all this area that has no water deficiency. I'm sure that would be news to the people in Georgia, Alabama, and Florida who are fighting over water at this time. But the clincher was out west. And so here's what they're looking at. They're saying, you know, if we don't have more water out here, that by the time we get to 1968, which this is, well, this is 68 here. This is the magic time here. That farm production is going to peak, and then it's going to start heading down while the population goes up very, very rapidly. And another view, same thing. Here we got food production, and it's going to go up just a little bit, and the food requirements are going to go straight up. What does this mean? It means that the government is going to have to spend billions of dollars every year shipping food out to California because they'll starve to death if it doesn't get there. So they have to have more water in the West. I mean, really, it was a vision of a third world country that was dependent on care packages to survive. They were just not going to have enough to eat out West, and it was going to be a drain on the nation. It was going to be a national security problem because we'd have all these weakened people out in the West Coast who didn't have enough to eat, and they'd be starving, and we'd have to, you know, pick up the pieces after them. So he needs this big plan to make rain out there. All right, so how is he going to do it? So they're going to have these command and control areas. And so these were the 8 areas that they were going to have as a command and control area. And this is what it was going to look like. I love this. So here's your command and control center. It has sensors that go to the reservoir, and it has ground sensors and water table sensors. And all of this stuff is looking at how much water they have. If it drops too much, then when a cloud comes over, they're going to send up drones. They're going to send up rockets. They're going to send up weather balloons. They're going to have weather satellites beaming down telemetry information. They've got a guy with an umbrella because they already know it's going to rain. And they've got all these gauges and snowfall indicators. And then when the water level is high enough, then it shuts it off. And all of it was going to be automatic. I mean, like nobody had to be in charge. It was just going to be automatic. And this was going to be so good that if you started at 1968, which was the beginning point of this, that within less than 20 years, half of the clouds in the country were going to be treatable. 90% of it would be effective. They anticipated that they had 30% effective in 68. Actually, they did not have 30%. Actually, all of these numbers are bogus. They're just made up. Down here, confidence that application of technology will result in target area precipitation increase, 90% by 1985. So they have anticipated that they can get this entire project to work in less than 20 years, that they'll be able to supply the entire country with water, that it will come in behind the reservoirs and the dams. It'll be there, it'll be ready for irrigation, and it will cost a fraction of the amount that it would take to build a whole bunch of new dams and reservoirs. Tens of millions of dollars a year is what it's going to cost. The legislators love it. They absolutely love it. Now, some people point out, you don't have any meteorologists working on this project. You only have engineers. And they said, yes. Next question. And finally, somebody says, you have to have a meteorologist. So they did. They hired a meteorologist to work in their Denver office. They had this program for atmospheric water production. And they went for it in a very big way. Now, all of this would have gotten completely out of control because they had excellent support from this guy. Okay, Lyndon Johnson, who never saw an earth science that couldn't be used for national defense or any other reason. And so when Lyndon Johnson's talking about environmental science, he's not talking about keeping frogs and spotted owls alive, right? He's talking about oceanography for anti-submarine warfare. He's talking about weather control. He's talking about overflights in South America so that we can help people find minerals that will be useful to them and of course to us. Wouldn't want to leave that part out. And so he has this big push for this. And in 1967, they had a big meeting in Washington, D.C. People came in from all over the world for this thing about how they were going to control the weather. And so there were like 3 big volumes of how they were going to handle water issues. And it was called, this program by now is called Water for Peace, right? We got atoms for peace, we got food for peace, we have water for peace. The Costa Rican government asked for immunization guns. They called that one pistoles for peace. So we have all of these peace projects. This one is water for peace. And so he's willing to put a whole bunch of money into this. What happens, however, is that by the early 1970s, there isn't that much money to go around for this project, and the droughts are over. And at the point where there was plenty of water for everybody, and there wasn't whole lots of water that anybody needed in particular, then interest died out. What had also happened was that this was after it had been, the government had been found out that they were doing secret and top secret seeding in Vietnam and Laos to try to wash out the Ho Chi Minh Trail. Now, we had already made a commitment that we weren't going to do that. Okay, well, so we did it anyway. And when the story broke on the front page of the New York Times, Seymour Hersh broke the story, there were a lot of people that were really upset. And therefore, then Claiborne Pell held a bunch of hearings, and you had all of these military people that were coming in who claimed that they had no idea that there was anything going on, and they were sure it wasn't happening anymore. Turned out that it was continuing to happen. Then the Nixon administration got caught, only they didn't even know it was going on. The military knew it was going on, but they didn't bother to pass that information along. So weather control kind of took on a not as favorable cast as it had. So you put all those pieces together and the project died away. Now we have a situation where the US government, other than the CIA, I don't know what the CIA is doing, all right? I do know that the CIA hasn't declassified their weather control work, and I know they were involved from other declassified documents that I have. But if you go to the CREST database, which is now online, so you don't have to go to Washington, D.C. to get onto it, that's all the declassified information from the CIA. And if you type in weather control or weather modification, all you get is what the Russians were doing. You don't get anything about what we were doing, which tells me that they're probably still doing it. But I can't trace that money, okay? It's money I can't trace. So what we have is that the government part of this died out and the commercial sector rose up. And so today in the West, we still have commercial seeders. We have governments that seed. So the state of Utah has a seeding project. State of Nevada has a seeding project. City of Reno has a seeding project. There's seeding going on in Arizona and New Mexico, all up and down the West Coast. It's still happening. It's done to control hail problems in Dakotas, because hail can really wipe out your wheat crop in just no time flat there in Saskatchewan and Manitoba. And so the idea is, if you have cumulonimbus clouds, here I am, I'm a big cumulonimbus cloud, you take an airplane up and you have the airplane fly around the outside edge of the cloud, because air is entrained into the cloud this way, and it takes the seeds inside and it basically breaks up the upward motion on the inside. The cloud collapses and it rains out, and it doesn't hail out. Rain is okay. Hail like this, you've got no wheat crop left. So that's what those folks are doing. State of Wyoming had a big $5 million project. They used their gas money because they got lots of gas, but they don't have enough water. Okay, so they use gas money for water. That's as opposed to using, in this morning's talk, where we're going to now break water apart, and we're going to use hydrogen to run our cars, right? It's kind of the flip of that. So if you think this is really over, no, it's not. National Research Council did a study in 2003. And of course, there is considerable concern with climate change now, that people will be interested in having water fall where it's not falling and not falling where it is falling, because we're looking at a situation where we'll likely have areas that are quite dry and other areas that will have an overabundance of water. And so, yes, people are still looking at this. Is it solid? Is there statistical evidence that it works? Only in a couple of very controlled situations. The atmosphere does not work like your lab. And that's something that Langmuir never understood. You cannot control the atmosphere. And you certainly can't control your own little corner of it unless you're just using smudge pots in your citrus orchard. Okay, I'll take questions if anybody has them. Yes.
Just like going forward, what do you think are the real ethical, like the main stakes at hand? Just being like, humans, like we dominated at this point, like the Anthropocene is what we're in, and like the responsibility that we have to kind of use these technologies, but also like not horribly disrupt more ecological patterns than we already have had in the last 200 years.
Okay, so the question was about the ethics of these kinds of things going forward, and this feeds into what's now known as geoengineering. So rainmaking really isn't geoengineering, because geoengineering is even bigger scale than rainmaking is. But anytime you have a situation where what you do affects other people, you've got a big problem, right? So everybody either cooperates or somebody's doing somebody else in. Because although like the rainmakers were very happy to tell you, so one of Crick's people, whose last name was, I'm not making this up, Hazard, was out in the state of Oregon testifying to their legislature. And they said, okay, but if we see the clouds here and we get rain, doesn't that mean that we've taken the rain from the people downstream? Mm-hmm. And he said, no. And they said, well, how do you figure that? And he said, well, because natural rain is just really inefficient. And so even if you double the rain here, 98% of it will still be ready for the people downstream. And even the math challenged legislators said, huh? And he said, yeah, that's right. Because he said, if that weren't true, he said, we wouldn't be able to sell our product to people all the way across the United States as it goes, right? So that's still really localized. That's still really localized stuff. And what we're talking about, if we're talking about trying to mitigate climate change, you're talking about a lot bigger area that has to be covered with this. And you can't just affect that patch and not affect the people that are downstream. So significant ethical problems, whether you're talking about this kind of cloud seeding, whether you're talking about putting iron filings in the ocean, which is some of the ideas that have been thrown out there, right, for carbon sequestration, whether you're talking about channeling rivers, places where they're not supposed to go, all those kinds of things, big ethical issues for the people downstream. People will be fighting over this, and it won't be pretty when it's done. Just my thought on it. Anyway, yeah.
The rain they create, is harmful to the crops if changing, you're throwing chemicals in to create rain? Wouldn't the rain that comes down be contaminated? How does that affect?
Okay, good question. So the question is, if you're putting silver iodide up there to make it rain, isn't that a problem? Isn't that problematic when it rains out? And the answer to that is, fortunately, no, because they've tested for that. And so it's such a minuscule quantity of this stuff, even though it looks like it's billowing up and it's doing something really exciting, it's just tiny, tiny, tiny bits of this. And it's way below anything that would be harmful. Now, it would be a problem if it had turned out that lead iodide was what worked. Fortunately, lead iodide didn't work, and so nobody was tempted to do that. But the silver iodide doesn't have a problem on plants, animals, or anything else, fortunately. Yeah.
So very seldom does research impact me. But today you've told me something that I've never known before. So my father used to curse the weather when I was younger. And now I understand why, because he was a legislative assistant for Senator Smathers.
Really?
He's not. So it's amazing, just think about the things that have to come in place for that to occur in one place. It's almost like rain making it rain in the middle of summer. Yeah, that's amazing. I had no idea he was that loon. But it explains a lot of things now.
Things you never knew before. Yeah.
Yeah, I did not know that.
Right. I mean, so what I've talked about here was how they were going to, produce rain that you could use. But I mean, part of this project also involved stopping hurricanes, and that was Project Stormfury. And Stormfury was launched from Florida. So they would send out planes and with metal canisters, and I don't have a photo of that right with me, but they'd send out canisters that were like monster flares, basically, and they would be punched out the bottom. If you're flying a military aircraft, here's your military aircraft, right? So there were places in the underbelly where you can shoot out sonobuoys and other kinds of things, right? Drop sons. And okay, so that's what they were doing. These went down like drop sons, and as they fell down, then they would spew out just like a flare that you would put out behind your car if you had an accident. And the idea was that it would break up the eye wall of the hurricane and cause it to shrink down and the outer eye wall to reform so that the eye would get bigger. And if an eye gets bigger in a hurricane, then the strength of the hurricane goes down, right? And so the idea was if you caught them while they were small, that you could snuff them out. And so that was the idea, is that you could snuff out hurricanes while they were small, and then they would never get in. Of course, another idea was that they were going to hit them with nuclear weapons, and you know, just like spreading a radiation around it with 100-mile-an-hour winds is no problem. Fortunately, I mean, that was in the New York Times, you know, thinking of using A-bombs, and I'm thinking, I hope not. You know, that's not a really good idea. But that is one of the top questions on the NOAA website. If you go to the NOAA website, frequently asked questions about hurricanes, it'll be, couldn't you just use an atomic bomb to knock it out? No, you couldn't do that. No, you couldn't. Yeah. Yeah,
So,
Julia.
Chris, watching the horrifying footage of the fire in Santa Rosa, California, and surrounding areas,
Mhm.
the question that pops into my mind every time I see that is, what can science do about that sort of thing?
Well, they actually had a plan for that I didn't talk about. That was called Skyfire. And the purpose of Skyfire was to seed cumulonimbus clouds so that you wouldn't have lightning. So that the idea was to stop lightning in the forest so that you wouldn't then have to deploy people to put out the fires. And if that didn't work, then you'd send them in again to make rain so it would put the fires out. So they would have viewed the Santa Rosa fire as, oh, well, here's a chance, you know, we'll go in and we'll hit some clouds. Well, I don't think they had any clouds, and quite frankly, they had already all kinds of particles that were already going up there anyway. So the big problem, of course, in California all this summer has been because of the big rain that they got last year. They had all kinds of growth that they don't normally have, and then it dried out, and then the air dried out, and then the winds came up, and so you have the fire weather forecasters kick in, and you can see, you know, if you look at Weather Underground or here locally, it'll tell you what the fire weather status is here, because that's a problem here with all those pine trees around us. You know, it doesn't take much, and you know, they're up. And so it's the same thing from out there. So the Skyfire people would have said, well, we need to bring in rain to kind of keep things dampened down so that we won't have a fire danger. But they wouldn't have used it probably in a place like Santa Rosa, because they were so concentrated on up in the mountains kind of places where it was hard to deploy firefighters. And they didn't, in those times, they hadn't quite come to the conclusion they could just let them burn out, and maybe that would be a smarter thing to do. And so they had guys in lookouts, and for younger people, they used to, in the summertime, college students would stay their whole summer at the top of tall lookouts. They'd climb up to the top, and with their field glasses, they'd watch for smoke. I mean, that's what they did for the entire summer. And so these guys would just look for cumulonimbus clouds, and they'd radio in. And as soon as they knew about that, then they would fly up to try to kill the clouds so that they wouldn't have the lightning, so that they wouldn't have the fires. And that was actually funded not by the US government. It was conducted by the Forest Service, but it was paid for by a private foundation, which I think has got to be one of the few times that a private foundation funded a government program. Don't ask, you don't want to know. Anyway, so anyway, that lasted until the 70s, when they finally put that one in the can, along with Stormfury, and all the rest of the weather control stuff went away. Yeah.
Do you see a lot of similarities today as to back in those days? I mean, this kind of weird science, political science, this you know, you're being negative about this, you know.
What I see is an unhappy parallel between this time in the 50s and 60s, where congressmen were making decisions about what science was going to get funded without understanding the science. And the scientists were having a hard time making a claim for what would have worked for them. So the Weather Bureau and meteorologists in general were trying to make a claim that they needed money for basic research into cloud physics so that they knew why it rained or it didn't rain to begin with. And the congressmen were saying, we don't care about that. We care about having rain where we want it to rain. We care about having clear skies in the Upper Peninsula of Michigan in the wintertime so that people don't get depressed. We want snow in the mountains so that we can ski, and we've got runoff during the summer. That's what we want. And we expect to get that because we're going to pay for that. And if you don't want to provide that for us, then we're not going to give you any money for that. And so now I watch some Congress people in action who are saying, no, I don't think climate change is real. The fact that we've got water lapping up in Miami, we don't have to worry about that. Sea level rise, like how high could it get? How soon could that happen? How strong could hurricanes be? It's just an odd year that all these hurricanes have hit, all of this kind of thing. And no real sense that they're willing to listen to people who actually know what's going on before they make decisions. That's what scares me. Yes, ma'am.
When you mentioned that they were throwing chemicals out the window in the airplane, were they like literally throwing chemicals out?
They were throwing dry ice out the window. So fortunately, they never threw chemicals out the window. Although they did spew out silver iodide seeds. So that generator that I showed you with the long tube. Okay, so they made smaller versions of those, and then they just put them on airplanes. And then they got to the point where they made them into flares, and they would just hang them underneath the wings of the planes, and then they would fly by, and then they'd touch them off, and it would all spew out. There were things done by military people who did throw things out, which I won't go into in this venue, which were explained to me at one point, but. For the most part, they were limited to dry ice and silver iodide.
So when they opened the window to throw out the dry ice,
Yeah.
were they affected by the air pressure?
They weren't up high enough. They were just going for a low cloud. Yeah, so they were okay. They were just kind of cruising along, looking for a little low cloud. But when they did this in India as part of a secret project that we did with the Indian government in 1967 to break the Bihar drought. They also took over unmarked Cessnas. They took the wings off and they shoved them into big airport transports, and they flew them over there and they were all unmarked. The people were not military pilots. They were people that were paid in cash and given special passports. And they were flying out, and there weren't any clouds for them to see. And so someone, I've never been able to trace back who, in the U.S. government suggested that they fly next to the border with China to see whether their anti-aircraft emplacements were working. And so they did. They flew over and they watched these shells arc over the tops of their aircraft and slice through one of their wings. Fortunately, they were able to get back, but they said, "Yeah, it works all right, and we're not flying over there anymore." Yeah, I found that out from the son of one of the pilots who contacted me just out of the blue. He said, "I heard you writing about this. I thought you might like to know." And I said, "Cool, way cool." Yes.
So how does this play into the Cold War and trying to modify weather against the Soviets?
Okay, well, so this is really a Cold War story because we were concerned. The U.S. government was concerned that the Soviets would know how to do this too. Because there was a meteorologist in Germany who was one of the first people to describe what could possibly happen if you tried to seed clouds with dry ice. And he disappeared after the war. Yeah, it turned out he was killed during the war, but we didn't know that. And so we automatically assumed that the Russians had him. And so that he was doing for them what Werner von Braun and his crew were doing for us over here. And so that we had to keep up because, as one general put it, the country that controls the weather will control the world. And so the idea was that if we could control the weather, we could starve out the Russians, right? Because they had a big land army, we could starve them out. If they were launching a tank attack, we could muddy up the ground, that we could make it big snow in Korea so that the North Koreans couldn't get over the mountains or the Chinese couldn't get over the mountains. So it was all tied up to defense because you couldn't prove you used it. Right? It wasn't like using nuclear weapons. You knew who launched a nuclear weapon. You couldn't tell. I mean, who could tell, right? I mean, it's not like the raindrops come with little markers on them, right? That says, "Yo, I'm a fake one," right? That wasn't there. So you couldn't trace it. You couldn't trace it back. So it was viewed as the military was the big push behind it to begin with because they were looking for a weapon that would be totally cool and untraceable. And that continued until they got caught, because they did actually use it in Vietnam and Laos. This whole domestic thing was a sidelight to keep the nation strong, the national defense strong, by keeping people well fed and happy and healthy, and water for agriculture and industry and that kind of thing. Good. Yes. Yeah, one more.
Did they know about like the water cycle?
Oh yeah, yeah. So they knew about the water cycle. They just didn't know why some clouds precipitated and some clouds didn't. That was still, I mean, they didn't know anything about cloud physics. Cloud physics was in its infancy at that point. They just didn't know. Okay, good. Thanks.
Thank you so much. We're going to take a 10-minute break, and then we will get started with our afternoon speakers at around 2:10.
I was just so wrapped up. I was just wrapped up when you said
Hey, Jesse. Hello, how's it going? It's going. How are you? Good.